So today we're going to talk about pyramids. And a pyramid is a solid with a base that's a polygon, and lateral faces that are going to be triangles. The vertex of the pyramid is the common vertex of the triangle. So the vertex then basically of the pyramid happens to be the common vertex of all the triangles. It's not the individual vertices of the base. It's just the point where all those triangle faces meet together. Then when we start talking about the altitude, well, the altitude happens to be that perpendicular segment, okay, that goes from that vertex down to the base. So we're looking for the altitude is the perpendicular segment that goes from the vertex to the base. There's also something called the slant height. The slant height then is going to be the height of the triangle that's on the side. So understand that even if you've got a height of the pyramid, you also have one of these triangles that's on the side, one of those faces, and they have heights as well. They have perpendicular segments too, but they're not the height of the actual solid. So we call those things slant height. So slant height is going to be this guy down here. It's going to be the height of one of the sides of the faces. So then the slant height is the height of one of the lateral faces. So a regular pyramid is a pyramid whose base happens to be a regular polygon. Don't forget, regular polygon means it's got the same exact size and the same exact angles. Alrighty, so then when we talk about a regular pyramid, the altitude is the perpendicular that goes from the vertex to the center of the base. To the center of the base. And whose lateral faces happen to be congruent isosceles triangles. Now hopefully that makes sense. So if we've got a regular bottom, and then we're going up to the same point, well, we have to go up the same distance to that point. So we've got two sides congruent for sure. Now the third side, the side of the base, could be congruent to those sides, but it might not be. So all of the faces, the lateral faces, are all going to be congruent isosceles triangles. So the lateral area is going to be the sum of the areas of all those lateral faces. Well, if you think about all the lateral faces, it's a triangle, and a triangle is half times the base and the height. Well, what we're going to do is we're going to kind of simplify this a little bit, and we're going to say that the lateral area is going to be equal to 1/2, and then we're going to call it LP. What happens here, though, is L stands for your slant height. I don't know why they use L for slant height, but they do. So L equals your slant height, and then at the same time, P equals the perimeter of the base. Okay, so we've got 1/2 the slant height times the perimeter of the base. If you want to find the area of all the different triangles, that's fine. You'll do base height divided by 2 times however many that there are. So then the surface area becomes the sum of the area of the base and the lateral area. So one way they write surface area is they say lateral area plus big B. Remember, B being the area of the actual base. So big B equals area of base. Or another way that we can say surface area is we could do it this way. We could say, all right, well then the surface area equals 1/2 LP plus area of base. Okay? So let's see what we can do in terms of some of these math problems. Let's hope the smartboard cooperates. Okay, we've got a square pyramid, and the measure of each edge of the square pyramid has 12 centimeters as the measure of each edge of the base, and the height of the pyramid is 8 centimeters. Find the lateral area and the total surface area. Well, if we take a look at this particular square pyramid, we see we've got 12 here by 12 here. It tells you that the height of the pyramid is 8, so AB happens to be 8. What we don't have, though, is the height of one of the sides of the triangles. We don't happen to have this slant height. That we don't know. So we're going to eventually have to figure that out. So we know that lateral area is 1/2 slant height times the perimeter. Well, to figure that part out, we know that the perimeter is going to be 12 times 4, which is 48, right? 12 plus 12 plus 12 all the way around. Well, let's see if we can figure out, in this case, the slant height. And you should see that there's a triangle that's created with the altitude of the pyramid, AB, half of the side of the base, CB, and then this piece that we don't have, which are it's really AC, I guess, that we're trying to look for. So I'm going to pull that triangle out. We've got this being A, this being B, this being C. Well, we already know that the altitude is 8, so there we go. CB is going to be half of 12 because it's going down from the altitude of the pyramid is going down to the center of the base. And then we need to find the slant height. That just happens to be a Pythagorean triple. If you don't know it, you do the Pythagorean theorem, but if you do, you find out that L equals 10. So our slant height here is 10. So then the lateral area equals 1/2 48 times 10, or the lateral area in this case is going to be 240 centimeters squared. We still need to find the surface area. So the surface area is going to be the lateral area plus the area of the base. So I'm going to do this. So then surface area equals lateral area plus the area of the base. The base we know is a square, which is 12 by 12. So the base we know happens to be 144. So the surface area becomes 240 lateral area plus 144 area of the base for a grand total of 384 centimeters squared. Surface area, lateral area, whole picture. Let's try the next one. Find the lateral area of a regular triangular pyramid whose base edge is 10 inches and it's got a slant height of 16. Well, slant height, we already know, happens to be L. We've got our base edge being 10. So it's a triangular period. Lateral area equals 1/2 perimeter times the slant height. Well, the fact that it's a triangular period, which I don't draw very well, but the sides or these edges of this triangle right here are all 10. Okay, so we're looking for then 1/2 slant height 16 perimeter, and then we get the lateral area in this case ends up being 240 inches squared. If we go on to the next one, surface area we probably should be doing, but it didn't have us do surface area. I don't know why. If we go on to this next one, find the altitude of a square pyramid if the slant height of a lateral face is 13 inches and the surface area is 360 square inches. This one's going to be a little bit more tricky, but should still be fine. So surface area we know is going to be 1/2 the perimeter times the slant height plus the area of the base. Well, as it turns out, when we figure out this square pyramid, so I've got this square pyramid, not drawn very well, but we don't know the length of a side. So the length of a side we know is going to be x, and it's all going to be x's all the way around. It's got the slant height being 13. So if I kind of think about dropping down the altitude into the center over and then a slant height, what happens here is I've got this altitude in here being unknown, but we've got this guy over here being 13. Okay, and then if we think about what we want to do, well, the perimeter of the square, so perimeter of the square when the sides are x is going to be add up all the sides, which is just 4x. The slant height in this case we happen to know, which is 13. If we do that and we think now about the area of the base is a square, which is base times height, which is x squared. I don't even have to draw this picture in here because it's not even necessary. So I'm going to get rid of this. And now we're going to kind of plug all these things in. So what we're doing here is we know for sure that the surface area they tell you is 360. So we've got 360 equals 1/2 perimeter, 4x, times slant height, 13, plus area of the base, or x squared. Looks like we're going to end up with a quadratic over here. So now what happens to us is we're going to do this. We're going to say, fine, then 360 equals, well, half of 4 is 2. 2 times 13 is 26x plus x squared. We, in fact, have a quadratic. We need to rearrange this quadratic so we can factor it appropriately. I'm going to subtract 360 from both sides, get the equation equal to 0. When you factor this thing, you get x plus 36, x minus 10 equals 0. When you solve for each value of x, you get x either as negative 36 or x is 10. We're going to keep the 10, but what it wants us to do, and now I'm going to go back up to the whole picture, it wants you to find the altitude of the square pyramid. So now what happens is if I pull out this triangle that we started to create over here, if we pull this triangle out, we know the slant height was 13. Remember, the entire length of a side is x. If this whole thing is 10, then half of it is 5. So the altitude that we're looking for is another Pythagorean triple. If you're not sure what the triple is, you need to do a squared plus b squared equals c squared. But it turns out that the altitude is going to be 12 inches. And that's it. Okay, so, not that it's difficult stuff, but stuff to definitely think about. Good luck on the homework.